Alright, we have to find the direction of the magnetic force on each of the four sides of the loop, or we can write 0 if there's no force. So let's consider the left side of the loop first. Well, the magnetic force on the left side goes as LIB sine theta, where theta is the angle between the current and the magnetic field. But if you'll notice, the current here points up, and so does the magnetic field. So theta is equal to 0 degrees, and so the magnetic force on this side of the loop is 0. Over on the right-hand side, we have a similar problem. The current points down, and the magnetic field, the external magnetic field here points up, and so the angle theta between I and the external is 180 degrees, and the sine of 180 degrees is also 0. On the top, we use the right-hand rule, L, I cross B, and we use the palm, thumb, finger rule. Well, if I point my thumb in the direction of the current, and my fingers in the direction of the magnetic field, then I get the magnetic force points out for the top. And for the bottom, I get that the magnetic force is in to the page. Alright. Now, as far as the torque, for part B, so that's part A. So the torque is mu cross B, or another way of writing it is that the magnitude of the torque is N I A B sine theta. Alright, now this is a single turn loop, so N is 1. The current of the loop is 3. The area of the loop is 0.15 squared. And the magnetic field that the loop is immersed in is 5. And now sine theta, well, this answers part C as well. The magnetic field inside the loop, if I look at any of these wires, the magnetic field is into the page on the inside of the loop, outside of the page on the outside of the loop. Right? You look at any of these wires, it's going to give you the same result. That means that the magnetic field of the loop points into the page, right? Now, this angle theta is the angle between the magnetic moment and the external magnetic field. Well, the direction of the magnetic moment is equal to the direction of the magnetic field generated by the loop itself. Okay? And they're 90 degrees apart because the magnetic field of the loop points into the page and the external magnetic field points up in the plane of the page. So this will be sine 90, which is 1. Alright? So if I multiply all these numbers together, I get that the torque is 0.34 Newton meters. There's our answer for part B. And then for part C, as I wrote above, the magnetic field generated by the loop is into the page.